Okay, hi everybody. I'm really sorry about the messed up video last week. I'm here to show you how to do the 3-point problems. So, hopefully follow along. Okay, I'm working on map A, and there's a whole bunch of different geologic layers here, and they go right across the center of the valley. So this is a valley, and you can see that because it makes a V shape in the contours here. And that means that since these are horizontal lines, that the valley walls are coming down like this. And downslope is this way. You can tell that because 300, 200 contours are getting down to smaller elevations this way. So map A is a pretty easy 3-point problem because you don't actually have to find 3 different points. You really find a line and 1 point. So let's say we're going to work on this contact here, which I think is the shale siltstone contact or something like that. Let me just check. Shale siltstone. Yes, it is. Okay. So I'm going to pick a contour that crosses my contact twice. And that's because as long as you're on a topographic contour, you know the exact elevation of your position. So if you're on the contact and the contour at the same point, the intersection, then you know the elevation of the contact as well. And since these bands that we see on the landscape are actually, they're the intersection area of a planar dipping bed or stratigraphic contact with a curved landscape, then we need to just find 2 points that are at the same elevation on that contact, and that'll be a strike line. So I'm just going to do the easiest one here. It's on the 325 strike line. So I know this is 325 because that's 400. I'll just label my strike lines. 375, 350, 325. So here's 2 points where the same contour is crossing the contact. So I'm going to connect those two. And that is strike of that contact plane. Okay, so my third point is just going to be any other point on the contact where I have known elevation. So I could go here, I could go here, I could go here. It doesn't matter. The important thing, I'll go here because it's nice and big contrast. The important thing is that, so what we're going to do, I know that anywhere along here that the contact is at 300 meters. Now, why does this look like I'm in the middle of the map somewhere and I'm not on the contact? Well, it's because the contact is dipping into the land surface. So, if the hill slope is coming like this and the contact is underneath the hill slope somewhere, it's only going to touch the surface at certain places, but the plane is still down there below the surface or still up there where it was eroded away. Like that plane as a geometric construct is still there. So I can measure from it even if I'm not looking at it on the surface of the earth. So here's another point where I know it's at 400 meters. That's up. That's above my 325 here. So already, which way is this plane dipping? The dip direction is perpendicular to strike. So strike is east-west. So the dip is either north or south. If it's at 400 up here, and then if I move north, it goes down to 325. The north is the dip direction. because that's the direction things are going down. So I'm going to draw a line from my known point here until it intersects this 325 point. And that line must be perfectly perpendicular to my strike line. So I'm going to use the edge of my ruler as a square. All right, perfectly perpendicular to my strike line. There it is. Okay, so since I'm measuring my slope, I now have a horizontal line whose length I can measure, and the distance by which the bed dips down over the horizontal distance is the difference between my two contours. So my point on my upper contour is at 400, and then I found another point on the plane, which is my strike line, which is at 325, so that'd be right down here where my finger is. My pen is the line in the dip direction that I just drew on the map. So now I can construct this triangle in the vertical plane using that line as the upper surface. The hypotenuse of the triangle is the dipping bed, and I know the height of the other leg of the triangle because that's my contours. Okay, so the horizontal distance here on my map is 23 millimeters. 23 millimeters. And on my scale here, I have 93 millimeters is 500 meters. So let me just go 23 millimeters times 500 meters is to 93 millimeters. 124 meters. Okay, so 93 multiplied by my conversion factor from the scale, which is 500 meters per 93 millimeters. My measurement's 23 millimeters, and that is now equivalent in my scale of 124 meters is the distance in the horizontal plane. So I can draw this. So here's my 400 meter point. Here's the projection of my strike line that's at 325. So I have 124 meters horizontal distance, and this is 400 minus 325, 75 meters. And this, my friends, is your dip angle. So tangent inverse of your dip angle equals opposite over adjacent, 75 meters or 124 meters. So what does that look like here? 75 divided by 124 equals dip is 31 degrees. Okay. So, since these edges of the map are north lines, you can measure the angle of your strike from here, and it's 92 degrees. So I might not have drawn it perfectly, but 092, 31 toward the, do you remember? North. Okay, so that's the easiest case, 3-point problem, because you can draw the strike line and then just drop one perpendicular to get you to the dip. So same thing on map B. Let's skip ahead to map C. All right, map C is meant to be tricky because most of these contours don't cross the beds twice. So let's say, maybe we want to focus on this contact. It's a nice one. So I've got a 500 point, a 400 point, and a 300 point on that contact. They're almost in line with each other. Okay, so if you think about it, if you have a shallowly dipping plane, the 500 meter elevation, 400, 300, there's a lot of horizontal space between those heights on the plane. The steeper the dip, 500, 400, 300, you don't have to move over as far to go down. So the fact that these points are kind of close together is telling me this is quite a steep plane. Okay, so here's the idea is that we have a high point, a low point, we have a medium point. Somewhere along the line between the high point and the low point has to be another point that's at the same height as our median point. So let's draw this line in from 500 to 300. I'm just going to make it slightly easier on myself pen-wise here. All right. Now, if the plane is planar, which it is, then if I go halfway down the line between 5 and 300, I should get to 400. So I picked this, of course, to have something that was a midpoint because it's just easy to measure. So, and I don't need to convert this to its true scale because I'm just going to take half of it anyway. So my total line length is 16.7 centimeters. So I'm going to go to 8.1, 2, 3, 5, 8.5. Boop. All right, so that gives me the location where the 400 meter contour lies on the plane. So now I have 2 points at 400 meters and I can draw in the strike line. All right, strike. Okay, don't worry about this first line you drew. You can erase it now because it's just what it is a very arbitrary line in the plane. So if I was going to do like as a little demo on this, I'll show you on my, can you see what I'm doing here? So here's a dipping plane on my iPad. So what I just did is I took a point that was at 500 meters. I took a point that was at 300 meters. And somewhere I had a point that was at 400 meters. And I wanted to construct another one. So I drew some line not the dip, not the strike, just somewhere in between on the plane. Found the midpoint of that, and then connected it to my 400 meters to make my strike line. So that's what I did in the reference frame of the plane. And I just showed you what it looks like on the map. Okay, now, do you remember what to do from there? Shouldn't be too hard. How many times can I say that? It's definitely hard. Everyone struggles with this problem. It's a lot to keep in your mind and flip reference frames from map view to cross-section view. Okay, but you have your strike line, which I've labeled here. And now you need to draw a line from your strike line known elevation to another point. So we might as well use one of the points we've already got. So this is 100 meters of elevation change in the plane. It's so short I don't even need to draw it with a ruler, but I do need to know its length. Is 9.5 millimeters, 9.5 millimeters times, what was our conversion factor? 500 over 93 is 51 meters. Okay, so in this case, I've got 51 meters at my 400 meter line. I've got 100 meters down to my 300 meter line. Whew. Dip. So again, inverse of dip equals opposite over adjacent. Dip is 89 degrees. It's practically vertical. I can't believe we could get this information from a map. Okay, so our orientation here, measure this for real, kids. Don't do as I do as I say. I'm going to call that 135. 89, which way is the dip direction? Well, here's our 400 meter strike line. We went northeast to get down to 300 meters. So the dip is that way. You can double check over here. If you've gone from your strike line to 500 meters, you'd be going up dip, and it would be southwest. So northeast, there is your answer. Okay, what is this useful for? You can use this little trick to project things like the location of a coal seam underground, to find out where a fault is going to crop out, whether it's going to hit a highway or a tunnel. Really anything where you've got some outcrop pattern on the surface and you're trying to figure out what's going to happen at depth. So variations on this are useful for every possible kind of problem you can imagine. Hope it helps.